4.2 notes. So the first thing we're going to do is we are going to go over our exponent rules. You have a base value. It can be in parentheses. It can be a variable. It can be a number. If there are no parentheses, then anything else written in front of that base is not part of the base with the exponent. If there's parentheses around the whole thing and then the exponent, then whatever in the parentheses is the base. I will show you some of these trick questions in a second. So a to the fourth is technically a repeated multiplication statement of a times a times a times a. Our product rule, when you multiply like bases, you add the exponents. So if the bases are the same and we're multiplying, you will be adding their exponents. So x to the m times x to the n. These bases are the same. You simply add the powers. So if I had x to the fourth times x to the second, 4 plus 2 is 6. This is x to the sixth. What we want to understand here is that we don't want to write out x to the fourth, 4 x's, write out 2 x's, and then count them all up to get 6. We want to use this shortcut. Here's an example of parentheses around my bases. X plus y is the entire base. They're both the same. This is to the power of 1. So if there's no exponent there, put a 1 there. 3 plus 1 will be 4. It's the binomial x plus y to the fourth power. Keep the parentheses. 2 to the second times 2 to the seventh. Do not change the bases. Some people accidentally multiply the 2's and call it a 4 and add the exponents. Not correct. Keep the same base 2. The base does not change. Only the powers will change. Your quotient rule. When you divide like bases, you subtract the exponents. So now the operators are opposite, so we should be doing the opposite to our exponents. So x to the m is on the top in the numerator, dividing it by x to the n power. You subtract the top power minus the bottom power, x to the m minus n. X to the seventh divided by x to the third, 7 minus 3 is 4, x to the fourth power. Here we have 3y in parentheses, that's the whole base. Here's another 3y in parentheses, same base. We're dividing them, subtract top down. 8 minus 2 is 6. All of the base 3y in parentheses to the sixth power. Here we have 4w to the fifth, y to the eighth, all over 10w, we'll put a 1 there, y to the third. What we want to do is think about simply reducing these as numbers, the variable w's, and the y's. So if I reduced 4 over 10, I can reduce that by 2. That's 2 fifths. W to the fifth over w to the first. 5 minus 1 is 4. W to the fourth stays in the numerator. Y to the eighth divided by y to the third. 8 minus 3 is 5. Y to the fifth stays in the numerator. And the golden rule that we like to use is whichever base has the biggest power, that's where your base stays. And we'll look at some examples when the bigger power on the base is in the denominator. But for right now, keep it simple. Zero exponent rule, a non-zero base to the power of 0 equals 1. So b is my base to the power of 0 is equal to 1, as long as my base is not a 0. So now this is the cause of trick questions. I'm telling you it will be on the test, but don't let me fool you. All right, so first example, 4 to the power of 0. That's 1. My only base is 4, the exponent 0, we're done. Now, in parentheses, negative 4 to the 0 power, the base is negative 4, all in parentheses, that whole thing equals 1. Now, negative 4, not in parentheses, raised to the power of 0, is a trick question. By definition of a negative number, whether it's on the inside of the parentheses or there's no parentheses at all, Negative 4 is technically negative 1 times 4, then to the power of 0. So even back here in the parentheses, I'd have negative 1 times 4, all in the parentheses raised to the 0 power. So right now, negative 1 is not part of the base of 4 with the exponent of 0. So 4 to the 0 is 1. Negative 1 times 1 is negative 1. The rule here is as follows. You probably heard of please excuse my dear Aunt Sally. You apply the exponents before you multiply. Parentheses around the negative, it's part of the base. Everything becomes a positive 1. No parentheses around my negative 4. You take 4 to the 0, which is 1, times negative 1. It is negative 1. Again, 5x in parentheses to the power of 0. The whole thing is a 1. 5x to the 0, no parentheses. Now this is 5 times x to the 0. 5 is not part of the base with the exponent of 0. So x to the 0, that part's the 1, times the 5 is 5. You got to watch these. I will fool you if you go too fast. Power rule. A power to a power, you multiply exponents. So you're going to see 1 base x raised to a power. This will be in parentheses and raised to another power. So you will multiply these. This is not like the product rule where there's 2 bases, 2 exponents, 1 exponent on each base. 1 base, 2 powers. Multiply the power. So if I had x to the 4th to the 3rd power, 4 times 3 is x to the 12th. Now, we might see extra bases in here. So here we have x squared y. We might want to put a 1 here as your exponent. Now this power of 3 has to be multiplied to every exponent on the inside. So this becomes x to the 2 times 3 is 6, 1 times 3 is 3, x to the 6, y to the 3rd. Trick question, probably see this on the test. Here's a number, it's your base 2. Do not go 3 times 2 is 6. Put an exponent of 1 on that 2 because this power of 3 can only be multiplied to exponents. 3 times 1, that's going to be 2 to the 3rd. 3 times 2 on the x, x to the 6th. 3 times the 5 on the y, y to the 15th. Now we simplify 2 to the 3rd as 2 times 2 times 2, which is 8, and that is our simplified answer. You will also see fractions in these parentheses. Same rule applies. This 5, put a power of 1 on it. This 2 gets multiplied to the 4 and to the 1. So this is x to the 8th, 4 times 2. 1 times 2 is 2. But 5 squared can be simplified to 25. Now sometimes they'll put some stuff in here where before you want to start multiplying in the exponents, you might be able to simplify this. So here, 6 divided by 3, or 3 goes into 6 twice, then put a 1 on it, x to the 4th, put a 1 on your y, z to the 4th, and now distribute that power to all your exponents. So it's 2 to the 3rd, x to the 4 times 3 is 12, y to the 3rd, 4 times 3 is z to the 12th, and again, as we saw earlier, 2 to the 3rd was 8. That's our most simplified answer. All right, now you will run into problems that have all kinds of things that you want to simplify. Always simplify inside as much as possible before you have to multiply this 4 to the inside, before you multiply this 3 to the inside. There will be things that you can simplify. So for example, y to the 0, that's just a 1 right here. So we really don't need that. You can scratch that out. But I did put a power of 1 on my 3. Second set of parentheses, 8 over 2. Well, that reduces to a 4. Use your quotient rule. All right, dividing my x's, 2 minus 1. Okay, that's x to the 1st. Y to the 5th divided by y to the 1st. 5 minus 1 is 4. Simplify that. See, now there's only 3 powers in this second set of parentheses as opposed to a 1, a 2, a 5, a 1, 1, 1. Simplify inside as much as possible before applying that power rule. So now that we have it simplified, we're going to take this forward. We're going to multiply it to the 1 and to the 3. 3 to the 4th, x to the 12th. Notice the 1 times 1, we don't need that anymore. 3 times the 1 gives us 4 to the 3rd, x to the 1st to the 3rd, x cubed, y to the 4th times 3, y to the 12th. Now we want to probably rearrange these so it's a little bit easier to read. And this is optional. 3 to the 4th times 4 to the 3rd. Bring the two numbers out front. This is going to be our big leading coefficient. But x to the 12th times x to the 3rd, I want to group these together because here I'm multiplying my like bases. I'll be adding these exponents. This will become x to the 15th. Y to the 12th will stay the same. And then 3 to the 4th, well, let's see. 3 times 3 is 9, times another 3, 27, times another 3 is 81. 4 times 4 is 16, times 4 is 64. Multiply these two together, 5,184, x to the 15th, y to the 12th. Make sure you show your steps in your work. All right? More is better when it comes time for work. If you miss a step and I don't see where the numbers are coming from, you will not get the points on the test in your work. All right, 4.2, negative exponent rule. There's 3 parts. All right? Now, first of all, if I had a to the negative 5th, how do you multiply this base to itself a negative 5 times? We're used to seeing positive numbers here. So if I have a to the negative 5th, which is technically over a 1, we're going to take it from the top and move it to the bottom. We're going to move the base and the power. But once you take this base and it crosses that fraction bar line, the sign changes to a positive 5. And that also works if my a to the negative 5th starts on the bottom with the negative exponent. We're going to take this and move it up to the top as a positive exponent. Now, if you happen to have a fraction inside of parentheses raised to a negative power on the outside, then you flip the whole entire fraction. A goes to the bottom, B goes to the top, all to a positive 1. So if this was a negative 3, then this would become a positive 3, and it would b to the 3rd over a to the 3rd. All right, write using positive exponents and then simplify if possible. So 2 to the negative 3rd. First things first, write it with positive exponents. That's like this a to the negative 5th. It's going into the denominator as 2 to the positive 3. Now I can find 2 to the 3rd. We saw earlier that's an 8, so 1 over 8. This is my answer. Don't give me a decimal answer. All right, negative 4 in parentheses to the negative 2 power. This negative 2, take the whole set of parentheses, negative 4, put it in the bottom, to the positive 2 power. Now, a negative 4 times itself, negative 4, is a positive 16. 1 over 16 is my simplified answer. Well, here's that tricky question. Notice no parentheses. So when I make my change here, this is negative 1 times 4 to the negative 2 power. Only the 4 is the base. Only the 4 with the negative exponent is going to go into the denominator with a positive exponent, the negative 1. Stays on the top. 4 squared, 16, so negative 1 over 16. 5x in parentheses, all to the negative 1. 5x in the parentheses goes into the bottom. Now, if you wanted to simplify this because it's to the power of 1, we don't need the 1, we don't need the parentheses. You can write it as 1 over 5x. Is it wrong if you leave the parentheses? Absolutely not. Oh, trick question, here we go. No parentheses around the 5x, so now the negative 1 is only on the x, so I'm going to write it with a multiplication dot. Move the x to the negative 1 into the denominator. I don't need the power of 1 anymore. It's 5 over x. All right, use exponent properties and write using positive exponents. Simplify if possible. Now, please keep in mind, there's more than one way to do these problems. X to the 6 times x to the negative 1 power. Multiplying like bases, add your exponents. 6 plus a negative 1 is x to the 5th. Now again, you could take x to the negative 1, put it in the bottom, x to the 6th over x to the 1st, and subtract the powers, and still come up with x to the 5th. All right, here, negative 5x squared y to the negative 3rd in parentheses raised to the power of 2. The first thing I would want to do is simplify this negative exponent here. Let's change that and put y to the positive 3 in the denominator. Okay, now remember this negative 5 is in parentheses, so you're going to be squaring the negative 5. 2 times 2 is x to the 4th. 2 times 3 is a 6, so y to the 6th. Simplify this as far as you can. That's going to be a positive 25, x to the 4th. A lot of people will confuse, oh, y to the negative 3, that goes on the bottom. Oh, my 5 is negative, I got to put that on the bottom. No, there's a positive 1 on its exponent. X to the negative 2 divided by x to the negative 7. Now, if you wanted to, you could just use the quotient rule and say this is negative 2 minus a negative 7, which changes this minus a negative 2 plus plus, or a plus 7, and negative 2 plus 7 is x to the 5th. Don't get me wrong, if you don't like negative exponents, you could have moved the x to the negative 2 to the bottom, x squared. X to the negative 7 from the bottom goes to the top as positive. X to the 7th over x squared. Now subtract 7 minus 2, you still get 5. Here, bases aren't the same, so all we're going to do is get rid of the negative exponents. X to the negative 3, we'll put x cubed on the bottom, y to the 6th on the top, and we cannot simplify it any further. Down here, let's do some simplifying first. Notice I can reduce the coefficients, the numbers in the front. I have x's top and bottom, y's top and bottom, so we're going to simplify that. So 5 goes into negative 10 and negative 2 times. X to the negative 3, notice I moved it to the bottom. And notice that z to the negative 2 from the bottom moved up to the top. So I can combine these two right here and make that now x to the 5th power. And then the y to the 1st over y to the 5th. Here's that one example I was telling you I was going to show you. Now the power is bigger on the bottom. So technically, this is the quotient rule. You would go 1 minus 5, which is a negative 4, y to the negative 4th power on the top, but then you have to move it to the bottom as y to the 4th. So one of our shortcut rules is that once all your exponents are positive, then you can go ahead and apply this rule. Wherever the biggest value is, the biggest power, that's where the base stays, and you just subtract 5 and the 1, and you get a 4. All right, here we have x squared over 2y to the 4th, all inside parentheses, to the negative 3rd power. Okay, negative on the outside. Flip the fraction on the inside. 2y to the 4th on the top, x squared on the bottom. Remember, 2 to the 1st, so that becomes 2 to the 3rd. Y to the 4 times 3 is 12. 3 times 2 is going to be 6. 2 to the 3rd is going to be an 8. And now we have simplified everything. Okay, next we're going to talk about scientific notation, which is used when we got to take very large and very small numbers and condense them so it's easy to work with. So here's a really huge number, and what we want to do is we want to rewrite this as some decimal number times 10 to some exponent. Now you know that whenever you multiply by a 10, you technically just put a 0 at the end of it. Well, this number here has had a lot of zeros multiplied to it, or I should say a lot of 10s multiplied to it. So those zeros are going to count as 110. We're going to count decimal places. So here I'm going to make sure that this n, which has to be between 1 and 10, it can be equal to 1, it just cannot be equal to 10. So this decimal point is over here, but for scientific notation, I'm just going to put it right after the 2. Now, how many decimal places are here to the right? We're going to count those up. And that will be the number of tens that we multiply by. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we'll count from over here. You can count in either direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That 20 is going to be the exponent on my multiplication of 10. So this is my scientific notation number. All right, over here, now my decimal point is here, but again, we need to be between 1 and 10. This number is not between 1 and 10, so I'm going to put the decimal point right after the very first non-zero digit. Oh, there it is, right there. So this is going to start out as 3.8, and now we got to count all these decimal places. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now we're going to take that 19 and we're going to put it on our 10, but notice this time it's a negative. All right? Now, rule of thumb is as follows. If my original number is greater than 1, which this was, you have a positive exponent, positive 20. If my number is really, really small, which is this number is less than 1, then you're going to have a negative exponent, and that's why we have a negative 19. All right, so we're going to convert our decimal notation, or we're going to convert our scientific notation to decimal notation. Excuse me, there I have a little behind there. So we're going to take this 10 to the 6th power, which is like multiplying by 6 tens, 6 zeros, or 6 decimal places. So we'll start with our decimal point, and we're going to count 1, 2, 3, 4, 5, 6. Since I had 3 little bumps here, I'm going to fill those in with zeros, and this would be my number in decimal notation. 3.62 times 10 to the negative 7. Okay, now it's negative. It's got to be less than 1, so now the decimal point has to count to the left. Positive counts to the right, negative counts to the left. So this is going to be 0.1234560, 362. Shortcut, I know I'm going to go over 1 decimal place. I got to count 7 decimal places to the left. Take away 1, put in 6 zeros. 4.9 times 10 to the 8th. I'm going to jump over 1, then I'm going to have to put in 7 zeros. 1, 2, 3, 4, 5, 6, 7. There's my number. 9 times 10 to the negative 11th. There's my decimal point. 1 hop over the 9, and then I'm going to need 10 zeros. 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, then my 9. Converting these to scientific notation, we want the decimal point right there at 8.1. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 decimal places to the right. So it's a positive 13 because, again, we started with a number bigger than 1. Here's a number that's less than 1, so we want the decimal point right after the 5, so 5.1. 1, 2, 3, 4, 5, 6, 7. 7 decimal places, but because it's less than 1, it's going to be a negative exponent. 1,439,000 decimal point will go right after the 1. Keep the 439. You can drop the zeros. 1, 2, 3, 4, 5, 6 decimal places, 10 to the 6th. Here we want 6.4189. You got to keep all these digits. We're just going to go 1, 2, 3. So 6.4189 times 10 to the negative 3rd power. Now, the reason we really like to work in scientific notation is because it makes multiplying and dividing scientific numbers incredibly easy because we're going to use our exponent rules. What we're going to do is we're going to use the commutative property of multiplication with our exponent rules because the commutative property says if I'm multiplying everything, I can multiply in any order I want. So if you think about taking 3.2 times 10 to the 5th, line it up underneath, multiply these two decimal numbers together, and I don't care if you use your calculator, all right, but notice the base 10s. They're same. Multiplying same bases, add the exponent. So 10 to the 8th times 10 to the 5th, that's now 10 to the 13th. That's done. This is the only thing my calculator has to help me out with. 2.5 times 3.2 is 8. I'm done. There's my answer. Do not, and I repeat, do not write this out as 2, 5, 7 zeros, 3, 2, 4 zeros, and start multiplying that all together. Way too much work. All right, next example over here. Let's take our second number that we're multiplying by, move it underneath. All right, now notice my base 10s. Add the exponents, 14 plus a negative 6, that's going to be 10 to the 8th. 8.5 times 7.4. Go to your calculator. I did, and I got 62.9, and that is not my answer. This first number has to be between 1 and 10. It's too big. So this decimal point has to be bumped over here between the 6 and the 2. Well, that would make it 6.29 times 10 to the 1st times another 10 to the 8th. So this first part is 62.9 in scientific notation. Now multiply your base 10s, add the powers, 10 to the 9th. So here's going to be a nice general rule. When you're going to be too big, when you multiply two scientific numbers together, even if it was 9.9999 times 9.9999, you will never get to something greater than 100. So you will never have to move that decimal point two places. It's always going to be 1. So if you're too big, just add 1 to the power and put your decimal point in the right place. So you can write this out, but then adjust it right to here. You don't have to show the step. It will never be more than 10 to the 1st. Okay, when dividing, okay, now we're going to put our fraction bar here. Now when you divide base 10s, you subtract your exponent. So this will make it 10 to the 3rd. Now we'll divide our first number. 7.5 divided by 1.5 is 5. We're done. 5 is between 1 and 10 times 10 to the 3rd. Over here, we have 2.4 times 10 to the 14th divided by 9.6 times 10 to the negative 6th. Subtract your powers. Now this is 14 minus a negative 6. That's going to give me 10 to the 20th power. 2.4 divided by 9.6 happens to be 0.25. Well, wait a minute. This is not between 1 and 10. Now I'm too small. Well, whenever I'm too small, I have to move the decimal point at least one place. It will never be two places. It will always be 1. So technically 0.25 is 2.5 times 10 to the negative 1 power times 10 to my 20th power. So now add your powers, makes that 10 to the 19th. So shortcut, when I multiply, if I'm too big, I have to add 1 to my power. If I divide and I'm too small, I have to subtract 1 from my power. Okay, and that wraps up our first video for 4.1 and 4.2.